Okay, so here what we want to do is we want to divide this problem. And when we divide, what we end up with is an expression like this, a plus bi, because this is a complex number. So when we're trying to divide, what we really end up doing is we end up multiplying the number by what's called the complex conjugate of the denominator. So when we take a look at this, the complex conjugate of 4 plus 2i is 4 minus 2i. So here's what it really looks like. If you look down here, here's the original problem. 2 plus 5i over 4 plus 2i. And what we're really going to do is take that original problem and multiply by 1. But we use a very fancy form of 1. We use the 4 minus 2i over 4 minus 2i, because this is still a 1. And now we're multiplying by the complex conjugate. And there's actually a rule there. When you multiply two complex conjugates, the result is going to be a squared plus b squared. In this problem, a is going to be 4 and b is going to be 2. So in the denominator here, we're going to have 16 plus 4, or 20. Now what we're left with is foiling the top. So here's where we are. We have 2 plus 5i, 4 minus 2i, all over 20. And we're going to FOIL. We have 8 minus 4i plus 20i minus 10i squared over 20. We're going to combine like terms. So I have 8 plus 16i. And here, whenever you have I squared, you need to substitute in -1 for that. So here we're going to have plus 10, because the I squared here is going to be -1. And all that's going to still be over 20. So we finish combining our like terms. We have 18 plus 16i over 20. And we need to simplify, so we factor a 2 out of the top, and we factor a 2 out of the bottom. Those cancel, and here's the final answer. Or almost the final answer. We still have to write it like a complex number, so that's a plus bi. And it looks to me like we need to continue simplifying that. This one is going to end up being, let's see, that'll be 4/5.